Dear students, Assalamu alaikum. Today we start chapter number 5, Operation on Sets. This is one of the easy chapter. Most of the topics are linked with the previous classes. First of all, we will study some previous terms, some terms which are linked with the previous class. Let us start. First of all, set. We will define set. What is set? In 19th century, George Cantor was the first mathematician who gave the proper idea of the sets that we are using nowadays in various branches of mathematics. Now, definition of the set. A set is a collection of well-defined and distant objects. A collection of well-defined and distant objects is called set. The objects are called its elements or its members. For example, remember that students, a set is represented by the following three methods which we already study in the junior classes: descriptive method, set builder notation, and tabular form. Descriptive method, tabular form, and set builder notation. These three methods are used to represent a set. In descriptive method, a set is written in statement form. In tabular form, a set is represented in two brackets. And set builder notation, this is a specific method in which we represent each element by a variable x. Now moving to some important sets, names of the sets, symbols of the sets, and tabular form. Set of natural number. Remember that students, natural number are always denoted by capital N, and natural number are those numbers which are start from 1 up to so on. 1, 2, 3 up to so on. So the second is set of whole number. Set of whole number is denoted by W, and it is represented by 0, 1, 2, 3. The difference between natural number and whole number is only 0. The natural number are start from 1 up to so on, and the whole number are start from 0, 1 to so on. Integers. Integers is denoted by Z, and this is equal to 0 plus minus 1 plus minus 2 plus minus 3. Set of even number. Even number are those number which are divisible by 2. 2, 4, 6 up to so on. Odd number which are not divisible by 2. 1, 3, 5 up to so on. Prime number. All those number which has two divisor, 1 and itself. 2, 3, 5, 7 up to so on. These are called prime number. Rational number. Rational number are those number which can be written by P by Q form, and this method is called set builder notation. This representation is called set builder notation. Now another term which is subset. It is clear from the name of this topics or name of this term, subset. Portion of the set, part of the set, subset. A set A is the subset of B if every element of set A is an element of set B. For example, if you have a set A which has element 1, 2, 3, 4, and you have a set B which has element 1, 2, 3, 4, 5, 6. Now we see all the elements of the set A are present in set B. 1, 2, 3, 4. The element of set A are already present in set B. So every element of set A is present in set B. So A is the subset of B, and it is denoted as A is the subset of B. This symbol is the symbol of subset. For example, formula. Remember that, students, the number of subset will be found by this formula, 2 power n, where this n represent the number of elements in any set. Types of subset. First type is proper subset and improper subset. What is proper subset? Definition. A set A is said to be proper subset of set B if A is the subset of B and at least one element of set B is not included in set A, as in the above example. Another example, if set A has element A, B, C and set B has element A, B, C, D, now the element of set A is present in set B, but D, this one element of set B, which is D, is not present in set A. So then A is proper subset of B, which is denoted by A subset of B. Formula is number of proper subset is equal to 2 power n minus 1. No improper subset. What is improper set? If set A consisting of all the elements of set B, that is A is equal to B, then set A is called improper subset of B. If all elements of set A is present in set B and all element of set B present in set A, then this is called improper subset. For example, if you have a set A which is 1, 2, 3, 4, 5, 6, 7, 8, 9 and set B the set of the first 9 natural number. Now both sets are same, both sets have the same number, so A is improper subset of B and it is denoted by A improper subset of B. Now moving to another term which is power set. What is power set? Definition. The set of all possible subsets of a given set is called power of that set. For any set A, it is denoted by P of A, power set of A. P of A means power set of A. Formula: to find out power set, number of power sets P of A is equal to 2 power n, where n represent the number of elements in the given set. For example, if we have a set A which has element 1, 2, 3, now number of elements is 3. Now to P of A is equal to 2 power n, so 2 power 3. 2 power 3 means 2 multiply 3 times. 2 2s are 4, 4 2s are 8. Like this. Now power set P of A. First we write empty set, then we write 1 elements in each bracket, like 1 in bracket, 2 in bracket, 3 in bracket. Then 1 with 2, 1 with 3, 1 with 2, 1 with 3. Then 2 with 3, 2 with 3, and then the all 3 elements. It means power set is the sum of proper subset and improper subset. Now moving operation on set. The first term is union of set. How we can find the union of sets? Union of two sets A and B is denoted by A union B. Union is always represented by the U, and it is defined as A union B is equal to X such that X belong to A or it is called or X belong to B. This is the mathematical definition of union sets, of this union of sets, union of two sets. How we can find union? Union means combining two sets. For example, if we have a set A which has elements 1, 2, 3 and we another set B which has element 2, 4, 6, then A union B. A union B is equal to, first we write set A, then union, then set B. Now combining these two sets, A union B is equal to 1, 2, 3, 4 and 6. Combining all repeated element we can write one time. It can be represented one time. Now intersection of sets. Intersection of the two sets A and B is denoted by A intersection B, and it is defined as A intersection B is equal to X such that X belong to A and X belong to B. In intersection we write common elements. For example, if we have a set A which has element 1, 2, 3, 4 and we have a set B which has element 2, 4, 6, 8. Now to find out the intersection of these two sets, A intersection B is equal to, first we write set A, then intersection, then set B. Intersection means writing common elements. Now 2 and 4 are common element in these both sets. So A intersection B is equal to 2 and 4. The difference of sets. The difference of two sets is denoted by A slash B, A minus B, and it is defined as A minus B, A difference B is equal to X such that X belong to A and X does not belong to B. Now for example, if set A is equal to 1, 2, 3, 4, 5, 6, 7 and set B is 2, 4, 6, 8, 10. Now how we can find the difference of these two sets? First, A minus B or A difference B is equal to set A difference set B. A difference B means write down all those elements which are the member of set A and not member of set B, like this. 1 is not present in set B, 3 is not present, 5 is not present and 7 is not present in set B. So A minus B is equal to 1, 3, 5, 7. Simply extra element of set A which are not included in set B. Now B minus A means extra element of set B which are 8 and 10. So B minus A is equal to 8 and 10. Now complement of the set. Another term is complement of S sets. Universal set. First we define universal set. A set consisting of all the elements under concentration in a particular situation is called universal set, and it is denoted by this symbol U. Now complement of set A. If A is any set and A is the subset of universal set, then the complement of set A is denoted by A dash or A power C and defined as A dash is equal to universal minus A. We will take the difference with universal. Then we will find A dash is equal to, and definition of this complement is X such that X belong to universal set and X is not a member of set A. For example, we have a universal set which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have a set A which has elements 2, 4, 6. 8, 10. Now we want to find the difference. So A complement is equal to universal minus A. Now writing A complement as it is, writing universal set, then set A. Now we taking the difference of this set A with this universal set. So the extra element of set universal set is 1, then 3, then 5, then 7, then 9. So A complement is equal to 1, 3, 5, 7, 9.